All right, we're going to start with day 2. This is in your student book on page 309. And we're going to take a look. We're going to review today with data representation questions. So let's first look at the first passage. This is going to be data representation. And we're looking at this graph, right? So go ahead and give yourself 4 minutes to do these 5 questions, and you can pause the video now and then start it when you're ready. All right, so we're going to start here with question 1. So question 1 says, according to the diagram, the trophic level at which the largest relative biomass is the... So the key word here I'm seeing 2 things. I'm seeing largest relative biomass and trophic level. So I'm going to try to find these over here on our graph. So if I read this here, it says, the ecological pyramid shows the relative biomass of organisms at each trophic feeding level. So I immediately know that this is showing me the relative biomass of organisms at each trophic feeding level. And the largest biomass is going to be the one with the largest number. So we see here the 4th degree consumers are 10 kilograms, then 100 kilograms for 3rd degree, 1,000, 10,000, and 100,000 for the producers. So our answer for the first one is producers. All right, so let's take a look at question 2. Question 2 says, from the information in the diagram, one can conclude that at any time, so this is just one, we're just going to have to read the questions and go through it this way. I read the question stems. 10 seals may be found for every mackerel. So I need to find seals on here. So I go over here and I see here are seals. I see the number 10, so this is tempting, but it's 10 kilograms. It's not 10 seals. So F we're eliminating, right? And remember on the ACT, it pays big time to guess, and if we can eliminate, that's even better. Let's look at G. It says the relative dry weight of all carnivores combined is far greater than that of herbivores alone. Well, first of all, I see carnivores and herbivores. So here on my chart, here are my carnivores, 1,000, 110. So it's close to 1,000. My herbivores are over 10,000. So the herbivores are greater than the carnivores, but this question's not what that's saying. So we can eliminate G. H, only 1% of all producers live long enough to be eaten by a mackerel. Well, where is this percentage coming from? Nowhere in our graph does it say anything about a percent. So we can eliminate H, so that makes the right answer for this one J. Okay, and just so you know, these first 2 are very easy questions. All right, let's take a look at number 3. Number 3 says, organisms from which trophic level are most likely to be found near the water surface where light can penetrate? Well, that tells us if they're near the surface where light can penetrate, they're probably plants, and they probably depend on photosynthesis. And so I look, and I see our producers here are photosynthetic protists. So these would be things that that would be near the surface. So that's going to be producers. They need to be near the surface because they need light. And let's do 4. 4 said if there were an additional trophic level of carnivores, 5th degree consumers, its relative biomass at any time would be approximately. So if there was something up here, what would its biomass be? And this one you have to see the pattern. Right, the pattern goes 10,000, then 1,000, then 100, then 10. So this would be, divide that by 10, right? It would be 1 kilogram. So the right answer would be F. Okay, and then let's look at number 5. 5 says the best explanation for biomass being measured as dry weight is, so I want to look for where does it talk about dry weight. So if I go back to my graph, right, I see on my graph that down here it talks about biomass is the total dry weight of organisms, and it says usable chemical energy stored in organic matter. So biomass is the dry weight or the usable chemical energy stored in organic matter. And if I go and look at my choices for question 5 says, or the choices are, if water weight were included, efficiency ratios at each trophic level would be unpredictable. Well, it never mentioned anything about efficiency levels, so we know it can't be A. B says body fluids contribute little mass to the mass of marine organisms. Besides not being true, it doesn't talk about that, so it's not going to be B. And then C says water molecules contain little or no usable chemical energy. Well, remember our sentence down here, biomass is the total dry weight of organisms, or the usable chemical energy. It would make sense they want to include water if it has no usable energy. So the right answer for this one is C. Okay, so those are the first 5 questions. Now we're going to continue. So just from page 309 in your book, we're going to flip to page 311. Okay, on page 311, this is our data for us to study. So again, don't waste your time looking at this. Go right to the questions. So we're going to go right to the questions, and we're going to start with question 6. So question 6. All right, so we look at 6. We'll shrink down the question here, and we want to find a relationship between approximate altitude and the approximate mean temperature. What's the relationship? So let's zoom this down, and we'll increase this here so we can see this. So I see here my altitude, right, and temperature. So I identify those from the question stem, and then as my altitude goes up, what's happening to temperature? So as altitude increases, temperature goes from 18 to negative 50. So it goes down, but then it goes up again, and it goes down, and then it goes up again. So it seems to be all over the place. So let's see which question stem best fits our problem here. So as altitude increases, temperature increases? No, that's not true. As altitude increases, temperature decreases, so G is not true. As altitude increases, temperature first decreases, then continuously increases. That's not true. It decreases, increases, then decreases again. So here we go. Here's our pattern, SPJ. It increases, decreases, increases, then decreases, then increases. So it's all over the place, the temperature, but the best answer there is J. All right, number 7. It says, based on the information in the table, the atmospheric layer with the narrowest range of altitude is the... So now I'm going to shrink that down and we'll zoom this up. So look here. My troposphere is here, stratosphere, mesosphere, and thermosphere. So troposphere is only from 0 to 12. Stratosphere is from 12 to 50. Mesosphere from 50 to 80. And then thermosphere from 80 to 60,000. So the troposphere only goes from 0 to 12. So that's our smallest one. So 7 is B. All right, let's take a look at 8. 8 says the type of clouds most likely to consist of ice crystals are. So the key word here is these ice crystals. So you'll have to know this from science or just know in general, but what temperature does ice form at? Well, it forms at 0 degrees Celsius. So whichever cloud we choose has to be at 0 degrees Celsius or below that. So we look and we see that nimbostratus and altostratus are at 18 degrees, but we do see, so it can't be nimbostratus and it can't be nimbostratus and altostratus, so it's between cirrus and cirrostratus or cirrostratus only. But if I look at this, cirrostratus is in the negative range, and so is cirrus. So it's going to be both cirrus and cirrostratus. So it's going to be, the right answer is going to be H and not J. Number 9 says the absorption of solar heat energy increases as the gases of the atmosphere become less dense or rarefied. The layer of atmosphere that appears most rarefied. So this is going to be, we see here a connection between solar heat energy increases as the gases become most rarefied. So heat is related to temperature. So the one with the highest temperature is going to be the most rarefied. So we go back to our graph here, and we see the thermosphere is actually at the highest temperature. So thermosphere must be the most rarefied. So the right answer for this one is A. And then let's look at 10. So 10 says, according to the table, which atmospheric layer shows a decrease in temperature of approximately 3 degrees Celsius for every 1 kilometer increase in altitude? So this one, we know that there's going to be a ratio of 3 degrees Celsius for every 1 kilometer. So let's look at our table and see if we can find something like that. We come here and we see the altitude difference here is 12. The temperature difference here is 62. That's close, but let's see if, so that's 62 divided by 12. Let's see if we get one that's closer than that. So here the stratosphere is 12 divided, or 50 minus 12. So that is and over here the temperature goes from 50 to minus 3. So that's a temperature difference of 48 over a difference of 38. So it's not that one, it's not that one. Mesosphere, the altitude difference is 30, and the temperature difference here is 88. So 88 over 30 is really close to 1/3. That's approximately 3, which is what we want. So the right answer is the mesosphere. All right, on page 299, we're going to encounter our second type of question, and that is a research summary question. So just to review some strategies for research summary. All right, so on page 299 again is our research summary, and a few things before we start that are different for this type of question. The first thing is I do think you should read this before you start the questions. It's a little bit different than data representation because information can be harder to find here than it is on a graph. So first thing I would say is read the passage, and as you're reading it, write the purpose and result of each experiment and ID the control. And I'll show you what I mean by this. Second thing is know the differences between all the experiments. I'll show you again how I would do this. And number 3, label anything that's a control variable. Okay, so what does this look like? So let's start by reading, and I'll mark it as I would if I were you taking the test. So to test the hypothesis that all antibiotics, so I'm going to circle this because this word is important. It's what the experiment is about. Are equally effective in preventing bacterial growth. So this is the hypothesis. We know that the antibiotics are going to be tested to see how effective they are in preventing bacterial growth. The following 3 experiments were carried out using clear plastic plates filled with nutrient agar, which and then explains a mixture of ingredients that supports the growth of bacteria. When bacteria reproduce successfully, colonies form on the agar, giving it a cloudy appearance. So this seems important. So when bacteria, so I might just do a quick note, bacteria equal cloudy. Okay, so let's go down to experiment 1. 3 plates of agar were set up, each with an equal amount of bacterial culture. So this equal amount, this is an experimental control, right? This is a control variable because we're keeping the amount of bacteria equal, are spread over the agar surface and with a paper disc placed in the center. Plate A's disc was soaked in antibiotic 1, so I'm just going to underline that. Plate B was soaked in antibiotic 2, and plate C was soaked in plain water. So this plain water, this is an experimental control. Because we're studying antibiotics, we have to have one of our plates with water so we can see if the antibiotics are different than just plain water, which we know isn't going to do anything. After incubation overnight at 37 degrees, so 37 degrees, everything is the same. So this 37 degrees is an experimental control. Plates A and B had a clear area, 2 inches in diameter surrounding the paper disc, but beyond this 2-inch region, the plates were cloudy. Okay, so plate C was entirely cloudy. All right, so here, so what I'm going to do to write the differences here, I'm going to say A and B, not cloudy. C, was cloudy. So then I'm going to go to experiment 2. Identical procedures were followed, except that plates A, B, and C were incubated overnight at 22 degrees Celsius. So this is a difference, right? 22 degrees. This experiment up here was 37 degrees. So that's one main difference. After incubation, plate A had a clear area, 2 inches in diameter. So that's the same, but plates B and C were entirely cloudy. So I'm going to zoom in here, and I'm going to write that A was clear, and then B and C were cloudy, and that's an important distinction to have. Let's take a look at experiment 3. Identical procedures were followed, except that the concentrations of antibiotic 1 and antibiotic 2 were made twice as strong. So this is a difference. So now we're making, it's twice as strong. The temperature is 22 degrees, and we see that plates A and B both had clear disc areas. So here I'm going to write A and B clear, and then C was cloudy. So let's shrink this down. So I've marked up my sheet, and so let me get rid of this, and let's take a look at the questions. Alright, so we'll go to question 20. So question 20 says, after incubation, a clear area around a previously soaked paper disc represents a region where, and then it said, so we should be able to get this from marking it up. We know that a clear area around the paper disc was, since bacteria make the appearance cloudy, then a clear area will be where bacteria growth did not occur. So this one is H. Alright, let's look at 21. So 21 says, which of the following results would indicate that the antibiotics being tested have nothing to do with the control of bacterial growth? So we know that our control was water, right? We used it here as our control, was that we soaked disc C in water. So let's go through our choices. So A says, a clear 2-inch region was always observed around the discs soaked in water. So what that would mean is that water wasn't allowing bacteria to grow either, so that the antibiotics also had clear regions just means that they weren't doing anything different than water. So this is a very strong possibility. But let's just check B, C, and D. B says all results remain the same at the 2 experimental temperatures and at the 2 antibiotic concentration levels. Well, if the results remain the same at the 2 experimental temperatures, even at the different temperatures, remember A and B were not cloudy here and A and B were not cloudy here. So even at different temperatures, A and B were working. They were doing something different than disc C, which was always cloudy. So this one is not the right choice. C, plates A and B always remained clear. Well, that's where the bacteria was. So the antibiotic was. So that would show us that the antibiotics were actually working. So it is not C. D says the discs soaked in water were not used in the experiment at all. This is a bad idea because we won't know if it was the antibiotics that were causing the clear area or if it was the water, but this doesn't tell us anything, so it's not D. So the right answer is A. And as you practice this more, you'll learn to kind of just see that, circle it, and you can move on. So let's look at 22. So 22 says, which statement is supported by the results of experiment 1 alone? So we know experiment 1 we have here. We see experiment 1 was at 37 degrees. So let's see. Choice F says antibiotic 1, antibiotic 2, and water are equally effective as inhibitors of bacterial growth. Well, in experiment 1, water made the bacteria cloudy, which showed us that the bacteria was growing. So it's not F. G, dry paper discs can be effective in controlling bacterial growth at 37 degrees. We didn't use dry paper discs, so it's not G. 22, the concentration of an antibiotic may influence its effectiveness in controlling bacterial growth at 37 degrees. Well, we didn't change the concentration of the bacteria at 37 degrees. It was only in experiment 3 that we did that. So we can't tell this from experiment 1. So it must be J, and J, just to check, both antibiotics 1 and 2 can inhibit bacterial growth at 37 degrees. Well, that's exactly what experiment 1 did, right? It took the 3 samples and put antibiotic on disc A and disc B, and we saw that growth didn't happen, so this is our right choice. All right, so let's go to 23. 23 says the results of both experiment 2 and experiment 3 lead to which of the following conclusions? So 23, so we go to experiment 2 and 3. A says antibiotics 1 and 2 have similar effects on bacterial growth regardless of concentration. Well, we know in experiment 2 that A was clear but B was cloudy. So they don't have the similar effects on bacterial growth. There is a difference. So it's not A. B said antibiotic 2 and water have similar effects on bacterial growth regardless of concentration. Well, we see that in experiment 2, B and C were cloudy, so they were the same. But in experiment 3, B was clear and water, C disc, was cloudy, so they have different results. So the concentration does matter because we increased the concentration in experiment 3, so it's not B. How about C? C says the effectiveness of antibiotic 1 at 22 degrees depends on its concentration. Well, antibiotic 1 worked in both experiment 2 and 3. So the effectiveness does not depend on its concentration. So it's not C. So the right answer is D, which, and if we check this choice, the effectiveness of antibiotic 2 at 22 degrees depends on its concentration. And we see that because here, they're both at 22 degrees, both experiments, but here, twice the concentration, antibiotic B worked, where antibiotic B did not work here. So it does depend on the concentration. So the right answer is D. So let's take a look at 24. It says, which hypothesis best explains the observation that the agar plates never appear clear beyond a 2-inch area surrounding the soaked paper discs? So we look at F. F says the bacteria cannot grow well within 2 inches of any moist paper disc. I don't think that's true because for the water, for disc C in each experiment, it was cloudy right up to the disc, right? And we see that plate C was entirely cloudy, including the area adjacent to the disc. So no, bacteria can grow right next to the disc, so it's not F. G says the antibiotics cannot seep through the agar beyond a distance of 2 inches. Well, since it was where the antibiotic was on disc A and B, and that's where it was not cloudy, this very well might be our answer. So G is probably our answer, but let's check H. At the experimental incubation temperature used, the 2 antibiotics interfere with each other's effectiveness. We never compared the antibiotics together on the same disc, so this doesn't make any sense, this H, so we can cross this off. And then let's look at J. J says the paper discs can absorb nutrients out of the agar from a distance of 2 inches. Well, if that was true, then the water discs would have had a 2-inch ring because they had the paper disc as well, but they had bacteria right up to the edge, so it's not J, so our right answer is G. And then 25, let's check it out. Okay, this 25, a little tricky, but let's take a look at it. It says if either antibiotic 1 or 2 could be prescribed for internal use, so that's inside the body, right, internal use, to prevent the spread of Bacterium X infections, which recommendation based on the experimental results is appropriate if the cost due to the amount of antibiotic used per dose is the most critical factor? So, in other words, we're trying to figure out, are antibiotic 1 and 2 equally effective, or do you need more dosage? Now, we did see that between experiment 2 and 3, that at 22 degrees, bacteria B, or antibiotic B, didn't work until you doubled the concentration. But this is room temperature 22 degrees. At 37 degrees, at body temperature, so this is where this internal use comes in, the antibiotics were equally effective, so there was no difference. So that tells me that it's got to be one where they're equal, and that is actually choice A. So this one is a little tricky, but it has to do with the fact that they said internal use, and so that only applies to experiment 1, and in experiment 1, A and B were both not cloudy, so So that tells us that they're equally effective, and therefore if cost is the same, then they will cost the same as well. Okay, so I hope that makes sense. I'll see you at day 3. As always, if you have any questions, email me. And here is my email if you would like to send me a question. All right.